But welcome to the first boot camp of the semester. And for those who might have missed it in my original description, the intention behind these boot camps is to kind of front the knowledge of what you're learning in the class so that when you go to class, you can just pick up and spend more energy learning about the concepts and the emphasis on the ideas that you're learning in class and not be so burdened with like learning Excel too. So a lot of these boot camps are designed to show you what it means to do statistics in Excel. So that way Excel is not a burden for you and you can just focus on the concepts itself. Now, even though I emphasize Excel a lot, I will be talking about some concepts related to the course because it's just going to be a natural byproduct of it. So you will get concept discussions in this too. But the overall emphasis is more about how to do calculations in Excel on statistics topics. And so that's one thing we're going to be talking about pretty heavily into these kind of things. And each week I do more different boot camps kind of ideas until we build out all the way throughout the whole course, which is about 16 of these boot camps in total. I will also be doing test prep workshops, which are much more content and concept focused and going over the big ideas like how you do a sample from a population, how do you know what is a high spread level, which you'll learn about later. What does all that mean? That will be in the test review workshops that I host, really usually about a week before your exams. So now let's get into the boot camp. So my name is James. Feel free to interrupt me when you have questions. I don't mind being interrupted. I like the dialogue and that kind of stuff. And so in the Excel document I posted in the chat yesterday, and again this morning, I believe, you will see different slides at the bottom, different sheets that we call them. And so down here at the very bottom is page 24, then calculation practice, word problem, and so forth. And page 24 is what we're going to first draw your attention to. Page 24, it might be 25 or 23 in your version of the lab manual. There are 4 versions of the lab manual out there. And so depending on which lab manual version you'll have, you'll find the page that has all the formulas they expect you to know how to use for Excel. And so in this version, page 24, we will see that these are the versions that they want you. Now, the good news is regardless of which lab menu you'll have, it's all the same essential functions. So it doesn't matter if yours is on 24 or 25 or 23, it's going to all contain the same ones. And so for your first test, for your Unit 1 test, they expect you to know how to use these Excel functions. And we're going to go over all of them today so that by the end of this, you know how to use each of these Excel functions. And we'll even talk about some limitations. So we're going to learn how to use the average function, the median function, the variation for population, variation for sampling, standard deviation of population, standard deviation of sampling, and how to find the z-score. And so again, page 24 in your lab manual, maybe 23 or 25, you'll see the same formulas. It might be slightly different formatted, but it'll be the same formulas. The one exception is some lab manuals contain the one on the right here, some don't. And the reason why is some instructors want you to use it and some don't care if you use it. It's either optional or required. If it's in your manual, it's a good idea that you use it. If it's not, like it's not on mine, then it's optional. And so I'm going to show you how to use it. There's going to be 2 different methods for doing this 5-number summary calculation, one using the formula and one without using the formula. I'm going to show you both methods. And in general, you can do it either way. Now, if your instructor, because they have the choice to, is explicit and say, use this formula, then definitely do it that way. If they tell you that you can do it either way, then obviously knowing both ways is good. There's advantages and disadvantages of using the formula or not using the formula. And you'll see that in action today. So on the first tab, we'll see calculation practice. And we have 3 columns of data. And I'm going to show you how to do these calculations, but I'm also going to show you some nice nuanced things about Excel. The very first one I like to bring to people's attention is if you're like me and you're just, I'm old, so I have like bad eyesight to an extent. One thing you'll notice in the very bottom right corner is this percentage meter. It says 80% on my screen at the moment. If I hit the plus sign, that just zooms in and you can make the font as nice and big as you need it and zoom in however you like. First thing, just to let people know, because sometimes students don't realize that you can actually zoom in and out on these cells. And so for each column, column A, column E, and we're here at column I have a long list of data. You can scroll down and see that the data gets really long. And by data, I just mean numerical values. And so I have a long list of data going on here. And what I want to do next to each of those, like in B, I want to find the mean, and then I want to find the median, find the population variance. And I'm going to show you a couple methods to actually doing these calculations using Excel. One is a little more slow and time consuming, and then I'm going to show you faster and faster ways. So the first thing I want to bring to your attention, to remind us from page 24, is to find the mean, you simply do equals average. And then this number one, number two thing just means you need to highlight your numbers. So next to mean over here in C1, column C, row 1, so C1, I want to write equals average and then hit parentheses, open parentheses, Shift 9 in most keyboards. That allows you to start entering your data. And the most common way is to click and hold the first value and then just drag down until you get all the values highlighted. And then just come up here and hit Shift 0 or close your parentheses and then hit enter. And there you just found the mean. But maybe they don't want the mean to 4 decimal places. Notice that mine defaulted to 4 decimal places. Maybe they want 2 decimal places. Well, the good news about Excel is you don't have to actually round a day in your life. Excel will do all the hard rounding for you. To do that, we're going to make sure we're on the home tab up here. Click on the number 51.7368, the calculation we just did. And in the center of the screen, you'll see these 2 0 options. One has the left arrow and one has the right arrow. The left arrow will add more decimal places, and the right arrow will round it to whatever level decimal precision you want. So if I only want 2 decimal places, I can hit the one on the right until it has 2 decimals. If I needed 7, I can go back and do 7. The good news is no matter how many you want, you don't need to round it yourself. Just click this little button and it will round it to the right amount of decimal positions that you want. So there's no reason to worry about trying to figure out, do I round up, do I round down? Don't do that. Excel can handle the rounding for you. So let's do the median calculation now. Median is just equals median. Parentheses, and then click the first one and drag all the way down to the last one. And then close your parentheses, hit enter, and you have your median. Population variance, that's going to be var for variance, but because of the population, we need to say .p. It tells the computer I want the population variance. So parentheses, highlight your data like before, close it, and hit enter. Let me scroll back and let you see what I did. So I did var.p, I highlighted my data, and then hit the close parentheses. So for var.sample, just mean var.s, S is for sample, open your parentheses, highlight your data, close your parentheses, and hit enter. That's all it is. And you'll learn in class, if you haven't started already, exactly what variance and deviation means. For us, we're going to worry about how to actually do the calculations now, so that when you're in the class, you don't need to worry about how to do calculations. You know how to do the calculation. You just need to learn what it means when you do the calculation. Why are these numbers different and that kind of stuff. So for standard deviation of the population, that is standDev for standard deviation, .p. Open your parentheses, highlight your data, close your parentheses. So notice it's pretty much consistent. You just have to know which formula to get. And if you ever get stuck and you can't remember the right formula, again, page 24, it tells you exactly what formula you need to get for each of these commands. And so if you need standard deviation of the sample, standDev.s. And so equals standDev.s. Parentheses, highlight your data. And the cool thing is it actually doesn't matter what order you highlight your data in. So I can start down here at the bottom and drag upwards too. And then close it and hit enter. If you wanted to, instead of dragging and all that, you could also just write equals standDev.s, and you can type in the name of the cell. So the first cell where the data starts is A1, so I can type A1. I hit colon. Colon tells Excel it means start and go to, so the colon means go to. And then you just type in the last cell, A19. And so that tells Excel to start at A1 and go all the way to A19. Close your parentheses and hit go. And so you can also manually type it if you prefer. And again, let's assume we want 3 decimal places. So I'm going to highlight all of our data, come up here to our zeros, and just keep clicking it until I get to 3 decimal positions. And notice it does them all at the same time to the same place value. And so whichever ones you highlight, it will change that place value. So if I didn't want to change all their place values, I can highlight only some of them and do the little 0 thing, and it will just change the ones I highlight's place value to whatever place value position you want. But yes, do not be rounding by yourself on all this stuff. It will do it all for you. So to find a z-score from a measurement, which you'll not need to know how to do for the first test, we have this formula right here called z-score. And so notice we're just going to use standardize. And then it tells you inside here what the inputs are. And so it's standardized of this X thing, and then mean, and then deviation. Obviously, it depends on which deviation we're talking about. Are we talking about the sample one, or are we talking about the population one? And you'll need to know from the question itself which one they want you to use. In a good story, are we talking about a sample or a population, which you'll learn more about if you haven't already in the class. This X thing is something that we often call the observation. Whatever it is you observed, what you seen, like a person's measurement, that kind of stuff. And so often another way is looking at thinking about it is a measurement. I'm just going to write the word measure here. And so we need the person or individual's measurement, and then the average from the data set, and the deviation from the data set. And so in our first case, it doesn't tell us we're talking about the population or sample. I'm just going to assume that we're talking about the sample. In real life, in a real kind of question, they'll have to tell you. But I'm going to assume we're talking about the sample because statistics is all about samples. And because statistic is a measurement of a sample, a parameter is a measurement of a population. The course is called statistics. So generally speaking, we're talking about samples. And so in this case, I'm going to assume that our z-score is of the sample. So when we do our calculation, we would first say equals standardize. And by the way, if you start writing it and you see it pop up on the list here, if it's highlighted, you can actually just push tab and it will autofill the word for you. Otherwise, you can just write the word standardize all the way out. Either way. And it doesn't matter if you capitalize or not, as long as you spell the word correctly. So the first thing we're going to need is our observation. And we're being told over here, the observation is 25, x equals 25. So we're going to write 25. And then comma, and the next thing we need is the mean. And we know the mean, we just calculate it. It's the one up here. But don't be tempted to write 51.737. Because remember, that number is a rounded number. If you use rounded numbers in your calculations, it tends to kind of make you off by a decimal or two. So be very careful. Instead, what we want to do is reference the cell, which we often call a cell reference. And to do that, there's 2 ways. You can just type the cell where the number is at, or you can just click on the cell. I want that one. And so the cell information in C1, that's where we found the mean. And now I need the standard deviation cell. And I tell you, we're going to assume we're talking about the sample one, but of course they have to tell you is a population or sample. In this case, we're just assuming they told us it was the sample one. So I'm going to click on the sampled value, that 33423 number. And you just click on it. Or type in C6 because it's in column C, row 6. Close your parentheses. And there's your z-score. And you'll learn more about what a z-score is and what its importance is and all that stuff later on. But it's a big part of the class, so be ready to get really involved in learning how z-scores work and why we care about them. For now, just more about how do you calculate it. That's what we just did. We found the z-score. Then this next part here, these 5 elements, that's known as the 5-number summary. And so if they ever ask you for the 5-number summary, they're asking you for these 5 things. And there's 2 ways of calculating a 5-number summary. I'm going to do it the longer manual way the first time. And then, as I said before, I'm going to show you faster and faster ways, because sometimes the manual way is just nice and easy. It's a good way of verifying your work. So the 5-number summary manually means that we're going to find each of these elements, one at a time. And usually the minimum, median, and max are the easiest ones because they have a very simple formula. If I want the minimum of data set, I can just write equals min for minimum. Open my parentheses, and then like before, highlight your data. Now, yes, this data is in order, but it won't always be in order. So it's not a bad idea to try minimum here. And then close it and hit enter. And there it finds the smallest number in your data set. If I want the maximum, same idea, equals max. And then, of course, highlight your data. Now, you might notice that on this particular list, there is no min and max formula. And so that means that they may expect you to do it a different way. You don't have to know it that way. And so an alternate way of finding the minimum maximum is to come up here to the very top. First, make sure you're on the home level. And then over here where you see A, click on the A. Notice what it does. It highlights all the data. Once you have that data highlighted, over on the right, and it might look slightly different, but over on the right here in general, you'll see a sort option. And for mine, it's under AZ in this little filter icon. If I click it and then click sort smallest to largest, it will put the data in order for you. And just tell it to continue with the current set selection. That way it only changes that one set of data and not mess around with everything else we've done. And so by hitting continue current selection, it will sort just these numbers. And now you just got to look at the very first number to get your minimum and the very last number to get your maximum. And then you don't need to worry about the minimum and maximum functions if you don't want to. Median, we already know how to find the median. We found it earlier, but just in case, equals median. And then highlight all of your numbers and hit go. So now these quartiles, the first quartile and the third quartile, if you're doing it manually, what it means is that they want the median. They want the median of the first half of data. That's called the first quartile. And then they want the median of the second half, or the last half. That's known as the third quartile. And sometimes you hear us call them lower or upper quartiles. Those words are used interchangeably in this class. And so the first thing we have to figure out is where our median is. This median represents the middle. And notice our median is right here at 64. So to help me identify that location, what I'm going to do is go to Home. And you see this little bucket? If you click on the bucket, it's just going to highlight that cell in yellow for us. That way I know where the breakpoint is. And so for the first quartile, I want the median of everything above that yellow 64. I want the median of everything from here and up. So I need the median of that group. That would be my first quartile value. And then the upper quartile will just be the median of everything below the 64. So you ignore that median location and then find the values of everything else. So the lower quartile then will be the median of this whole group above that 64. So to start at the 59 and go up. In other words, A1 through A9. And notice my median is 15. And so just so I know where it is, I'm just going to highlight that quartile. It's right there at 15. And then I want the upper quartile. So I want the median of everything after 64. And so the median after 64, well, that starts at this 70 number and it goes all the way down to the end, which is 81. So I'm just going to highlight this number. Now, why am I highlighting it? Just one, so I can see it in my data set. But one thing that you should notice is even though I found 3 numbers, what I did was break my group into 4 groups. Notice how many numbers there are above 15. There are 4 numbers. And then how many numbers are between those 2 yellow groups? There are 4 numbers. And then between 64 and 81, there are 4 numbers. And then after 81, we have 4 numbers. And so what it did by finding those quartiles was break our data into 4 equal groups. Don't really care that they're all 4. It just happens to be 4 equal numerical groups. There's 4 in this group, 4 in this group, 4 in this group, and 4 in that group. It could have been 5, 5, 5, 5, or 10, 10, 10, 10. The whole idea is we want to find the breakpoints that break these up into essentially quarters. That's 1/4 the data, 1/4 the data, 1/4 the data, and so forth. And so that's what quartiles mean, like quarters. You're breaking the data into 4 nice groups, and you're trying to find the values that do that. But that represents the 5-number summary. And there's a question later on that will actually ask us to do something with it. Just an FYI. Now, I did it long way. Now I'm going to show you a couple of nice things about Excel that allow us to do this process a lot faster. First thing I want you to know about Excel is Excel doesn't really care if you precisely highlight your values. And so what do I mean by that? Well, let's do the first calculation, average. Often when you're trying to drag by hand, you're like going, you're like, oh man, I went way too far. Well, it turns out for Excel, it doesn't care if you go too far. You just can't go too short. So if you get all of your numbers in extra white space, you don't need to go back and painfully try to get it right and go, oh, I went too short, too far. And Excel doesn't care. You can have these empty cells and it won't change the calculation. So watch, this one I went way too far. And my answer is 511250. On the next one, I'm going to precisely highlight, so equals average, and highlight just the numbers I need and hit go. And notice it's the same calculation. Just one's in 4 digits and one has 3 decimal places. And again, if I fix the decimal rounding, you'll see it's the same calculation. So you don't have to worry about being very precise and trying to go back and forth and getting frustrated. Just round at least to the data, you can go beyond it. And so for median equals median, highlight your data. And again, you can go way past it. It's okay. Excel is not going to care. And you get your solution. Maybe I only want 1 decimal place. We know to go up here to the little decimal zeros and just keep clicking. You go down to 1 decimal place. For the variance of population equals var.p. And I want all the data. Now there's a real nice shortcut that I'm going to show you. Before I kept clicking and dragging, right? Well, if you recall, when we were doing the quartile thing, we could actually just click on this letter up here, this E, because all of my data is in E. So if I click the E, it will automatically highlight. And what it does is it highlights the entire column. And yeah, that's way past it. But remember, Excel doesn't care if you go way past it. So you can be very fast and just click the letter up top here, and it will highlight all of your data, hit enter, and boom, you're done. No dragging whatsoever. So if I want the sample variance, var.s, parentheses, and then just click on the E. Don't worry about dragging. The only time you get to drag then is if your data is not a nice, neat column. So obviously it'd be to your advantage to put your data in a nice, neat column. So you can just click it and hit go and get your calculations. Population standard deviation, that's standdev.p, parentheses, click on the E, close your E, and hit go. And you now can find the standard deviation population. If I want a sample standard deviation, standdev.s, parentheses, click on the E because my data is in the E, close your parentheses, hit go. And so this E:E just means all of E. It also means that if you want, instead of clicking things, if you're not a person who likes clicking with your mouse, you can also just write standdev.s E:E, and that just tells it all E. If I wanted all A, then it would just be A:A, and so forth. And so you can also just manually type if you prefer typing right on through. Everybody has their own way of liking to do it. All right, z-scores, we learned that earlier. That's standardize. And so I see it popping up down here, so I'm not going to hit tab and it'll auto-complete. My x value is given as 25. My mean, we calculated up here. And again, we're going to click on the cell, and we're not going to try typing because it's not exactly that number. And for us, we're just going to assume for today that we're talking about the sample standard deviation. Obviously, for the questions, you're going to need context to know which one to actually pick. But for this, we're just going to assume for simplicity, they're talking about the sample version. And so I'm just clicking on that one. And I could also just type in G6 if I prefer and hit go. And so there is my Z-score. And again, in class, you'll learn what this actually means later on. And we'll actually have a word problem that we're going to utilize and talk about what it means a little bit today. Our data this time is not in order. So what I'm going to do is click on this E at the very top to highlight all my data, and come over here to my sort icon again, and just tell it, put in order from smallest to largest. Always make sure you just do your current selection. If you have one data set, if you had two data sets, you can expand. But if you have one data set, just continue at the current selection and click sort. And now it's in order from smallest to largest. My minimum value was 1. My maximum value is 100. Maximum value is 100. Now I need to find the median, which we already know. It's 48, but why not have Excel do the calculation again? It's not bad practice. Median of column E. Close it and hit enter, and there's my median. Now, one thing you'll notice in this case is my median is not here. There's no data value of the median. The reason why is if you look carefully, and one way to show you, I'll show you this actually. If you click on E, one thing I want to draw to your attention is down here at the bottom right. It gives you some quick stats down here. It gives you the overall sum, something we don't generally use in this class. It tells you how many numbers there are, and it tells you the average right there. And so we see the average is 51,125, which is what we calculated when we did the mean. So when they say average, they mean mean. But the thing that I actually want to bring to our attention right now is the count. The count says 24. That means that we have essentially a middle value, and then we have 12 above it and 12 below it. So this number is not going to be in there because of the even number of numbers. And so this 48 won't be in the data because it's in the middle of the data set. There's 24 numbers, which means there's 12 above and 12 below. Before, when we did A, we had 19 numbers, which means that there's an extra number, there's an odd amount of numbers. So the median will be in the data set. So if you have an odd amount of numbers, your median will always be in the data. If you have an even amount of numbers, your median can't be in the middle of the data. Or can't be in the data itself, it's between the data. So here we have a number of 48 as our median. And so we just got to identify where that would go. And that would be right here between 43 and 53, right? That's where our median is. That's where 48 is. And so to get our lower quartile then, we want the median of everything above that value. And for our upper quartile, so this is the lower quartile group, for our upper quartile, we want the median below that group. And for our lower quartile, since we want the median of 12 numbers, that's an even number. So we know this quartile, which is the median, the lower group, right, will not be in the data set again, because it's, an even number. But the even number, it has to be between the numbers. So we want to find the median of this 12 data set. So median of these top 12 numbers, the lower values. And we get a calculation of 28. And so that 28 would be right there between 26 and 30. That's exactly where the lower quartile is. And if we check, we have 1, 2, 3, 4, 5, 6 numbers there, and then 1, 2, 3, 4, 5, 6 numbers there. So we broke it into equal groups, which is what we're trying to do. We're trying to find a nice breaking of groups, so we have an even amount of numbers between our quartiles. And so far we have 28 as our lower quartile, 48 is right here, and we just need to find our upper quartile, the median of the upper group, for the higher numbers. So median of these higher numbers. Close it and hit go, and we can see it's actually at 71.5. And so between 67 and 76, that's about where 71.5 would be, right? Between 67 and 76. And so that's the upper quartile. And again, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I know I did it right. Your quartiles should break them into equal groups, the same number of numbers in each group. And so I broke each one into 6 elements, essentially. And so that's my calculations. But that's, intense. That's a lot of labor. Wouldn't it be nice if Excel had a fast way of getting the 5-number summary? Well, it does. That's that command over here that I told you is optional if you want to use it. And it's called the 5-number summary. And it's really beneficial if you have a large data set. In fact, it can be done on a small data set, but it's not too hard to do it by hand when you have a small data set. That's often why we only usually use it for big data sets, but you can do it any one. And this one in particular is relatively big. Look how far down it goes. It goes way down here. And in fact, if I just click on the I, we can see that there's actually 397 numbers. And yes, it gives me my average too if I want it, my mean. But of course, I don't want to handwrite that stuff. I don't want to handwrite 49.896725544. We're going to have Excel just write that answer down for me. And so to get that, I can say equals average. And remember, just click on the I. All of my data is in that nice tight column. And so if I click on the I and hit enter, I have the average, that same calculation we just saw. If I want the median, median equals median. Parentheses, click on the I, close your parentheses. Population variance, var.p. Click on the I, close your parentheses. Sample variance, this is things that we've done a couple of times now, so click on the I and close your variance. Population standard deviation, that's standdev.p, parentheses, click on the I, close your parentheses, and there is your standard deviation. Sample standard deviation, that's just standdev.s for sample. Parentheses, click the I, close your parentheses, and you have your sample standard deviation. And we've also done the z-scores now, right? Stand, you can either write it all the way out, or once you have enough where it isolates it, just hit parentheses, and it will auto-populate. The value in question is 25. Our mean, we just calculated 49.8967, but remember, click it. And we're assuming sample standard deviation, so click that value as well. Close your parentheses and hit enter. Now for this one, the minimum quartiles and all that stuff, I really don't want to go through and try to figure all this out manually. So we're going to use the Excel way. And to do that, we have to do one little setup. In the column next to where we want the answer, we're going to write 0, 1, 2, 3, 4, just like that. The reason why is Excel is going to read that column to know which calculation you want, because this one function, quartile.inc, does the entire 5-number summary, not just a single part of it. It does all these calculations at once. So what I'll do then is equals quartile.inc. Notice there's 2 of them. For this class, we use .inc. And we go parentheses. The array is Excel's fancy way of saying the data. And our data, we know, is in I. So just click on I to get all the data selected. Then push comma. And now we want to be able to click on the cell where that 0 is. Notice right now I can't click on it because my formula is blocking this cell. So there's no way to get that cell. And it's tempting just to type 0 and enter it manually. Problem if you do that is it won't automate the process. So what we're going to do to fix this instead is I'm going to temporarily erase this. Sorry up front. But all you have to do is go up here to where the K and L is. If you slowly go between the two and then hold down your mouse, you can drag and make the cell a lot bigger. That will allow you to fit your quartile.inc in here. Click on the I's, and now notice that 0 is no longer blocked. I can now easily click on the cell where the 0 is. And I don't have that problem of it trying to be blocked by my command. You can just drag your cells larger, in other words. And so now by clicking on the 0, what's going to happen now, after I hit enter, I can go back to it. And if you look carefully, I'm going to zoom in so you can see it better, but if you look carefully in the bottom right corner, there's this little dot, this little square. What that square does is Excel is asking you, do you want to automate it? And if you do, you just double click that dot really fast 2 times. Boom, boom. And notice what it does. This part doesn't have any numbers next to it, so it just gave me a bunch of extra zeros that don't mean anything. But more importantly is it did my calculation for me. It found the quartile. It found the median. It found the third quartile. And by the way, 1 is for first quartile, 2 is for second quartile, known as the median, and 3 is for the third quartile. And then, yeah, 4 is the max and so forth. The other option, if you don't like double clicking, because not everybody does, you can just click on that little square and just manually drag down, and it will repeat that formula for you. But that only works if you click on the cell 0 instead of typing. If you physically type a number, when you try to drag it down, it's just going to repeat that same formula over and over again. And that's not what you want. You want each of these calculations. So again, when you get to the second box part where you got to enter in what you want it to do, just click on the 0 that you wrote earlier. And now you can click on the little corner and either drag it or double click it, and it will automatically update your formulas. And so there is my 5-number summary done really, really fast. Now you might be like, James, why don't we just always do it this way? You totally can. You can always just use quartile.inc. One thing I do want to show you, because sometimes people will get some answers that look a little different. And your class should be set to do both answers, but you might see your instructor's answers and be like, well, why is mine different from my instructor? Why am I not getting the exact same numbers? And so I'm going to show you what happens at quartile.inc and why we tend to not do it with small data sets. And so let me just click on the eye up here, right click, and you'll see a menu pop up, and I can click insert just to scoot the data over a column. And so I'm going to do the whole 0, 1, 2, 3, 4 like we just did. And I want to do quartile.inc for this data set to be able to compare it to the ones that we did manually. And so I'm going to go equals quartile.inc, INC. And my data is in E. And then that 0 I want, can't quite get to it because, again, I didn't move over. I happen to know it's in I8. So I'm just going to write I8 manually instead of worrying about adjusting my cells, because I know I8 is, I and 8 of that cell where the 0 is. So you can also do it that way if you don't like dragging the cells bigger, or the columns bigger. But there's my quartile.inc for using that 0 value. Now again, if I go back, grab this little dot and drag, I will get all of my quartiles like before. And notice that when you do the quartile.inc, the minimum, the median, and the maximum are always identical. But these quartiles, quartile 1 and quartile 3, are generally speaking going to be slightly different answers. Both answers are correct, and you can use either method. Just understand that if your instructor did it manually and you go to turn your work in, they're going to look a little different, but technically they're both right, and you can do it either way. Now, if your instructor tells you, I want you to do it this particular way, then do it that way. But this is how we calculate, especially in the real world, how we use 2 different methods. Both sets of values will still break your data apart into groups of 6 or groups of whatever, 4 groups of whatever amount we're looking to break it into. So both ones give you the right kind of values to do what you're trying to do anyways, which is why it doesn't matter which method you use. The one on the left is how we did it manually. If they ever say do it manually, this is what they're talking about. And then this one on the right is by formula. And so if they tell you, I want you to do it by formula, they want you to use quartile.inc. If they say do it manually, then they want you to physically go through and find the median, and then find the median of the upper half and the median of the lower half, and so forth. But again, both methods will give you 3 of the identical values that will always be the same numbers. It's just these first and third quartiles, you get slightly different answers depending on which method you use. So that's the major calculations in Excel that you need to know how to do for this first test. But let's actually look at some of these problems in context of when we actually use them and try to interpret it a little bit. And then at the end of this, I'm going to show you how to build a histogram. So let's jump over to word problem number 1. I'm going to be quiet for a second, let you kind of internalize the question, think about how you would start it, and then I'll start talking. And so where do these questions come from, by the way? It came right out of your lab manual. And for those who don't know where the lab manual is, in Blackboard, you have a free downloadable lab manual. It's usually found under course resources. So if you don't have that lab manual, please get the lab manual. It's a big heads up. The instructors who wrote the lab manual also wrote all of your tests. So how they phrase the questions and how they set the questions up in the lab manual is generally the same kind of wording you're going to see on the tests. So yes, the homework and other kind of stuff is nice and important, but that lab manual is the most important study tool you can have for these exams. I don't care how well you know the homework. If you don't know the lab manual, you're in trouble. Always know the lab manual. That should be your fundamental go-to resource. And again, in the lab manual for every single unit is a page dedicated to all the formulas you need to know how to use in Excel. And yes, you will use Excel on your exams. So be ready for that. So enough blabbing. We see that we're trying to find z-scores, and they're giving us different observations. We saw somebody with this temperature, we saw somebody with this temperature, and then we saw somebody with this temperature. And after we find the z-scores, we'll talk about what this means. We're going to figure out, is anything unusual? And if it is unusual, we're going to try to figure out what does it mean to be unusual. And in this case also, notice they're giving us the mean up top here, and they're giving us the deviation they want us to use. So all we need to do is calculate the z-score. And so the first one, we have equals standardize, right? Because that gives us a z-score. The first observation is 97.5, so you just write 97.5. In this case, they're giving you a mean instead of like a cell reference, so you can actually type this one in. That's okay, 98.2. And our deviation is 0.62. And so you just type it all in. And there's your z-score. And so another z-score, standardize. Then again, write the whole word. You can abbreviate it by quickly hitting tab and auto writing it, whatever. The observation is 99.6. The mean given is 98.2. And the deviation was 0.62. And of course, the 0 part is optional, but I write it out of habit. Close it and hit enter. And there is my z-score. Last one. We have and it's standardized, right? We want a z-score. Observation is 98.2. Mean is 98.2. And the deviation is 0.62. And so there is our last z-score. And don't freak out if you see positive or negative or even 0. That's absolutely fine. Now, to answer the next question, this is how you find the z-scores, but let's actually talk about briefly what does it mean to be usual or unusual. In statistics, especially when you're talking about z-scores, well, we have something called the empirical rule, and you'll learn more about this in detail in the class, but essentially anything that's more extreme than 2, so a z-score that's bigger than 2, or a z-score that's smaller than -2. So if you see a value positive or negative that's larger than 2, so 2.5, 2.9, 4, 16, -2.9, all those numbers are considered unusual. If it's really positive, then we call it unusually high. And if it's really small, then of course, unusually low. And so examples, of course, of 2 is like 2.6. That's unusually high. Or a negative version, -2.8. That's unusually low. But something like 1.2 or -0.4, these are considered usual. We don't like to say the word normal, but it, you can probably get away with that in most things. In the real world, we would not use the word normal because that refers to a certain kind of data set, but it would be usual. Or another word you can often see is expected. So you would expect numbers to be between -2 and 2. That's normal or expected or usual. Again, I know I just said normal, but it's something that you kind of expect to see. Anything that's really more extreme, higher than 2 or more negative than -2, is unusual. So of these 3 scores, which one is unusual? Right there, 2.258. And because it's bigger than 2, it's unusually high. And so in this story, we're talking about body temperature. What do we call it if your body temperature is unusually high? Well, we would say this person probably has a fever, right? Their body temperature is really high. It's unusually high. This person's temperature is a little low, but it's not unusually low. And this one is like exactly what we think it should be. We think it should be 98.2 and their temperature is 98.2. So there's no difference. That's why the value is 0. This one is just slightly less, and hence it's a negative 1.13. While B is considerably higher than what it should be. And so you will tell this person, your temperature is unusually high. You probably have a fever. Now, not everybody likes the standardized command. So there is a manual way of doing these calculations for z-scores. And I'll show it to you really fast. If you want to find a z-score manually, what you'll do is the observation, whatever measurement we're looking for, and you'll minus the mean. And often you'll see us use a symbol like this for mean, this weird kind of U thing. And then we're going to divide it by the deviation, that weird kind of omega symbol there. It's actually not omega, I forget what it's called, but that symbol right there means standard deviation. That's your standard deviation. So if I want to do it manually, what I would say is equals my observation, let's say for B, was 99.6. And I want to take away the mean, minus the mean of 98.2. So that's the difference. And what you're going to do is take that difference. All I did was the subtraction. You do that first. And now what we want to do is divide. So this line here, of course, means division. And so we're going to divide that value. We're going to divide this value by the standard deviation. And so I take that 1.4 calculation and divide it by 0.62. And notice I get the same calculation that I get from using standardized. And so you can do it either way. It just looks a little different because it's currently rounding, but we know we can undo the rounding by going to home and clicking the zeros to add more decimal places. And you see it's exactly the same number. So you can do it manually if you prefer. I don't, and so you'll see me throughout this course always using standardized, but you can always do it manually. And some people get brave and write this as one big equation. And you can write equals, but if you're doing the subtraction first, you need parentheses. So you can say 99.6 minus 98.2, close your parentheses, and then divide by the deviation, 0.62. And so you can type it as one giant expression if you prefer and get your calculation that way. And so notice there's 3 different ways to do it. You can just do it step by step, manually. You can write the whole thing as one giant expression, or you can do it James's preferred way and just write in standardize. I just prefer this way because it's less slinky on my part. But whatever method you like, use that method. As long as you're getting the right answer, no one's going to really care in the end. And yes, so we would say this person's a fever because their value is unusually high. Let's try another one. Give it a read. I'm going to be quiet a little longer than last time because I want you to actually try this one. Okay. So first off, you might not see any kind of key phrase that we know, but some things that we can pick apart on this question is we can see we're getting an average and a deviation each time. We're giving another average and then a deviation. So we're looking at some kind of calculation that uses average and deviation. And one thing that you'll learn more about in the class, when you see this word relative, it's referring to a statistical concept called relative standing. And that simply means then is find the z-score and compare. So in this case, we don't care if the score is significant or not significant. We don't care if it's bigger than 2 or less than -2. We just want to know when you compare apples to apples and oranges to oranges, who has the better z-score? And what do I mean by apples and apples and oranges? Well, one of these people, they are a biathlete. They are like one of those marathon runners who will run and then like I think they swim and then ride a bike, and that's actually a triathlete. They'll do two things because they're biathletes, right? So they'll run and maybe bicycle. And so they'll do like multiple things. And that's a different kind of athlete than this person who's a speed skater. And so it's not really fair to compare a biathlete to a speed skater. They're just different sports. It's like asking me to for you to compare this person who's a wrestler to this person who's a chess player. They're just different kinds of people. It's more fair to compare the wrestler to other wrestlers and see how well they stack up, and that chess player to other chess players and how well they stack up. And so relative standing simply means when you compare them to their own group, who is more unique from their group. And so that's the general idea of what's going on here. And so we're looking for the relative standing of each person. How different are they from their groups? And so let's make some notes on here then. So the first person we can see on here was the biathlete. So I'm just going to write biathlete. And then the other person was a speed skater. In both cases, they have their own actual scores, which we call X. That's their observations. How fast do we see, or whatever we see them doing. That's what we call an observation. And then we have our mean that we're going to need and our standard deviation. And so for the biathlete, their actual score, or age in this case, we see them, was age 35. That biathlete tells us in the question that biathlete is 35 years old. That's the information we have. The mean or average of the biathlete is 27.3. So we're going to write 27.3 here for our notes. Try that again, 27.3. There we go. And then my standard deviation for the biathlete is 4.7. The speed skater, though, their age, their data set we were given, well, it's 33. It says the speed skater got at 33 years old. And then their average value was 23.1, and the deviation for that group is 3.9. So a couple things to notice. One is the biathlete, yes, they're older than the speed skater. But again, it's not necessarily fair to compare them that way, because in general, on average, biathletes are older than speed skaters. So we would expect them to be older. So the question is this person much more different from their group than this person? And we're going to utilize the z-score to kind of make that judgment call. And so it's the z-score that's going to allow us to decide who is more different from their group. And so we're going to find some z-scores. And so we're going to need standardize. Again, we have our observation, X, just clicking on it, then the mean, and then the deviation. Hit go, and I have my z-score for the first one. The biathlete's a z-score of 1.64. The speed skater, again, standardize, click the 33, click the 23.1, click the 3.9. And so when compared to their own groups, who was the more unique individual? The speed skater. Their z-score was higher. Now notice for relative standing, we don't actually care that it's above 2. We just want to know who has the higher score, who is more unique from their group. It's more unusual to see a speed skater at this age than it is to see a biathlete at their age. Because again, this is obviously normal, it's within 2, but more importantly, it's just a higher value or more extreme value. And so the speed skater is more unusual, it's a higher value than the other one. So who is the one that's actually older or higher than the comparative group? From their own group, the speed skater is. They're statistically more unusual to find someone that age because their z-score is bigger. Obviously, if it said who is younger, then I would care about the smaller z-score. And there we go. And so that's some of the basic calculations going on. But now let's actually get into histogram, which you're going to get really involved in soon. And it's going to become one of the biggest calculations you'll make for test 1. And so what I did was kind of delineate or broke down into very small, minute steps. And so you'll see in general, there's about 10 steps we would do in going to make a histogram. When you get good, you'll learn how to combine these, kind of go a little faster with it. But for now, so you kind of learn how it works, I broke it down to 10 very detailed steps. And what we're going to do is go through each step one by one as we get these calculations. Just checking the chat real quick. Okay, I don't see any questions, so I'll keep going. So in order to get these things going on, the first thing we're going to need is calculate something called the range. And the range is simply the biggest number minus the smallest number. And in order to take advantage of the expediency, you can either put your data in order, which we know we can click on the A, go home, and sort smallest to largest. And again, continue with current selection and hit sort. Put your data in order essentially. And, your lowest numbers on top, your biggest numbers on the bottom. And you can do it that way. If you prefer and you're like me, you can also just simply say, find the maximum number in this data of A, close your parentheses, and minus the minimum number. Excel doesn't care if you write multiple formulas in the same cell. And then go A and close your parentheses. Always notice whenever I want Excel to do math, I always got to write equals first. When you write equals first, that tells Excel I'm doing math. If I don't write the equals and I just write max of the data, it's not going to know I want to do math. It thinks I'm writing a word. But by putting an equal sign in front of it, it will know all of a sudden I want to find mathematically the maximum value. And so it's very important if you're writing a formula or telling to do any kind of math, always start off with an equal sign. Just a little nice fact. So that represents our range of values. That's the biggest number minus the smallest number. The next thing it's asking for is to simply identify how many classes you want. That's another way of saying how many bars or how many groups are you going to want. In this case, they have to tell you this. Generally speaking, it's either going to be 5 or 6, but they can tell you any number they want. And so let's assume they're telling us 6. And so we now know our classes. But again, they have to give you that information. The general default, though, if they don't, they just forget to do it, we usually go 5 or 6. Now, the first thing we want to figure out is our class width. And that is no more than the difference of the range, not the difference, but the calculation of the range that we just found divided by the number of classes. That is our exact class width. And so I'm going to simply go equals, click on my range cell, and divide it by my number of classes. So D2 divided by D3. And that will give me the exact class width. Now, why do we have an exact class width and a rounded class width? Well, to be honest, a lot of times we do this by hand, and it's not going to be fun to try to use this number and count and do math on those numbers. So almost always, it's to your advantage to simply round this number to something nicer. But what could you pick to round it to? For the most part, you can pick any nice number you want that's bigger than that calculation. Hence, I tell you to round it always up. So I could pick, if I want to, the number 15. That's not a bad number to use. I could try 20, and you'll see what I mean by try in a little bit. I could pick 16. I could pick 19. Heck, if I want to, I could pick 15.12345. Do not recommend that. That will, again, be just as ugly as using 14.833333. So in general, you want to pick a nice looking number, a number that's easy to count by. And so generally it'd be some kind of number like these, 15, 20, 16, 19, something that's nice and whole. And usually kind of pick either 15 or 20 or 25, some multiple of 5. But you have flexibility there. You can pick any number you really want. The only catch is when we start going through and looking for the frequency, and I'll show you how to do that in a little bit. When we go through the frequency, we technically always want numbers in the first row and numbers in the last row. If we ever have 0 numbers in either of these 2 boxes, it means there's something wrong with your rounded class width or you picked the wrong first number. We'll fix the first number problem where this will never be 0 on the next step. But the last row here could end up with 0 data points. When that happens, it means you chose a number too big and you need to go back and adjust it. And so what I'm going to do first is just pick a number too big and show you what I mean. And then we'll go back and pick a much smaller number that works. So let's say I choose the number 20 here. I think, okay, well, 14.8, that's close to 20. I'll try that. And we'll see what happens. So the LCL is your lower class limit. It's the smaller number in the range. And usually for our simplicity here, we like to pick the minimum number. Doing that will always guarantee that the frequency at the lowest number has a data point. It will have the minimum number. So it's to your benefit, but you really don't have to. You can actually go smaller than that. But it's to your benefit to just always pick the smallest number in your data set. So for our LCL, I'm going to pick the smallest number, which is I put them in order I know is at 104. But if I wasn't sure, because maybe I didn't put it in order, I could just say minimum of my data in A if it wasn't in order. To do this, you're going to need them in order anyways, so you can kind of see your minimum right there as well. But you see your number is 104. And then what this class width does, the reason why we care so much about this number right here, is the class width tells you how much to count by as you go down. So going down each time, if class width is 20, means I want to count by 20 every time going down. Not this direction, not sideways, but going down a row, I want to add by that class width. So I want to add 20 every time going down. Now, of course, I could do it manually, but Excel can do it for us. And here's how we'll automate it. We're going to click the first cell underneath the 104. And we're going to say equals. And then we're going to click on that 104. And so notice how it says F8. It's referencing the cell. If I add 20 to it, put plus 20. If I hit enter, it did that math one time, but now I can go back to it. Because I have a cell reference part, I have the F8 in there. If I go back to it, I can grab that corner if you recall. And that will tell Excel to redo that calculation over and over and over again. And it does all that math for me really fast. And so I now have all of my LCLs inputted for me. Your UCL is simply one number before the next LCL, because we want this to be a range of all the numbers leading up before 124. So if this is 124, then the first UCL should be 123, because we want this one to start, or stop, I should say, right before where the next one starts. And so we always want to go back one number. One thing to be careful about, though, is technically this is 123.9999 on forever. It's always going to be before that cell. We just often write the whole numbers, especially when you're dealing with just whole numbers. We don't need to be very careful about the nines. If you had decimals in your data, then you would actually need to kind of match how many decimal places you have, because technically this UCL goes all the way up to, but not the next LCL. And so this first value, then, if that's 124, this UCL is 123. And then like before, we're going to say equals, click on the one above it, and say plus 20, because that was my chosen rounded class width. And I hit enter. And so if I go back to my data, grab that little dot and maybe double click, I can see it going. It went a little too far, which is why we often just drag, but that's okay. I just highlight those values and hit delete to remove them. But again, if you just clicked and dragged from the 143 down, it would do the addition for you either way. And so now what this represents is it tells you what the groups are. So the first group, the first class, starts at 104 and it goes up to 123. And so your frequency is just how many numbers in the data set do that. And so starting at the 104, we want all the numbers up to 123, but not past. So no 124s or bigger. And so notice it's just those four numbers. Four numbers are from 104 to 123. So I can write 4. And that's it. From 124 to 143, the first number in that range is this 134. And I can go all the way down until I get to 143. And so that's 1, 2, 3, 4, 5, 6. And if you're ever not sure, remember, we can look right down here and it's giving you the frequency. That's also known as the count. So there are 6 numbers in that group. Then we need 144 to 163. 144, 163, but you can't go past it. So I have a total of 5 numbers. And we just quickly do the rest of the values like that. Up to 183, and I can see it's 6 numbers. And then 184 to 203, and I see it's 4 numbers. But notice there are no numbers in this group. That's a no-no. We don't like having either the first row or the last row having 0 numbers, because essentially that means that you don't have a class here. We don't care if you have zeros between the rows. That's actually okay and meaningful. We just don't like it when the first row or the last row has 0. And again, if you pick your minimum value to be your first row, which we did, right? We picked the minimum value to be the first one, that will guarantee that this is never going to be 0. But the last row could be 0. And when that happens, it means that your rounded class width that you choose, and you get to choose your rounded class width, was chosen to be too big. And so that means we have to go back and pick a smaller number. And if 20 is too big, the next kind of nice one to work with is probably this 15. And so all that means is I should have picked 15 as my class width. So I'm going to go back, grumble a little bit, because yes, I know it's extra work. And then we're just going to adjust our chart to count by 15s instead of those 20s. And it's not so bad to update it. If you click on the 124 2 times, you'll see it pulls up your original formula where I wrote plus 20. And again, all you do is click on the cell and you just keep clicking on it till your formula shows up. And so I can just edit it, remove that 20 and write 15. Hit enter. Now go back to my 119, grab my little corner and drag it down. And it does my edit, it updates my calculations. Now each of these are counting by 15s instead of 20s. The only thing to be careful, if you recall, is your UCL should be the one previously. So 123 doesn't make sense anymore. That number should actually be 118. And it'll be the one above it plus 15. And now if I go back to it, grab my little dot and drag it down, I get them all automatically updated to be counting by 15s. I like my frequencies because this is going to probably be wrong now. And we can do a quick spot check. We know this one's going to work because there's 104, so you're going to have guaranteed frequency here. Let's just run down to the bottom and make sure we have a number between 179 and 193. And we do. We have numbers between 179 and 193. So we're going to have data in this last group. So we're good. That's actually a good class width. We just have to make sure there's data in the first group and data in the last group to know you picked an effective class width. And so 15 will work. It also turns out that 16 and 17 will also produce. Other values beyond that actually don't work, which is why you can have different choices for class width and it still work out. So now we just need to find our frequencies. So we want a frequency count from 104 to 118. And like before, we're going to start at the top and just go from 104 to 118, which is those 4 numbers. Then 119 to 133. Just look where 119 would start, 133. Notice there is no number from 119 to 133. The smallest is 114 and it jumps to 134, and that's 0. But again, in the middle here, we don't care if there's 0. You can have gaps in the middle. You just can't have a 0 at the beginning or the end. So now 134 to 148. 134 all the way to 148 includes all those numbers. And you can see down here, it says the count is 8. And so there's 8 numbers there. 149 to 163. Starts at 156, up to 163 is only those 3 numbers. And then 164 to 178, starting at 164. And 178, so it's a total of 1, 2, 3, 4, 5. I can also look right here and see that it's 5. And so I know we have 5 numbers. And then the last group, 179 to 193. So 179 will be these last 5 numbers. And a good way to check your work is you can add up the frequencies and compare it to the overall count. So if I want to make sure, did I get all the numbers? What I can do is say equals sum. Sum just adds up your numbers, and highlight my frequencies. What it's going to do is tell me how many numbers I put here, what the total value of the numbers I put there. So the total frequency is 25. And if I click on this A and look down here, what do I see? I see that there's 25 numbers. So I got the right amount. There's 25 numbers. I counted 25 numbers, and so I feel pretty good about my calculation. Okay. Let's get the last little parts of our frequency table done, then I'll show you how to make the histogram. So relative frequency is just the frequency divided by the total. And we already know the total is this 25 I just found. That's how many numbers there were. There are 25 numbers. So we're going to say equals. We're going to click on the frequency because we want that value to change each time, but I don't want the total to change. The total is always going to be 25 because that's how many numbers there are. So divided by 25. Notice I key in, we call that hard keying when you type in the number, but I cell referenced the 4. The reason why I do that is now when I hit enter and go back to it, I can grab my little dot here and I can drag it down and get all of my calculations done really fast. Now, in this case, it's already defaulting to a percentage, but it may not. And so let me show you how to change it. In general, it's going to actually say general or number up here, and you'll see more like a decimal version like this. And so if I need a percentage, you don't need to do it manually. You can come up here where we saw the zeros, and right above it, we see a percent sign. Just click it, and it finds the percentage for you. It converts it to a percentage. Now, everybody has the percent option, so if you click the down arrow, you can also find it in this list right there. If you click percentage, it will turn it into a percentage. And then we're going to adjust how many decimals we need based on the question. Cumulative frequency just means the adding on of the frequencies. So adding on the frequencies. So the very first value is 4. So we're just going to start off with the 4. Then we want to add on each row as we go down. And again, we want Excel to automate this for us. I don't want to have to do all this by hand, especially when you got really large numbers. So we're going to say equals. We want to take the information that we know above it and add the new row to it. So in this case, we're going to add the 0 to it. And we know 4 plus 0, that's just 4. You could have done that in your head, no doubt. But now by doing the formula way, if I come back to the dot, I can just drag it down and it will do all that addition for us. And it's going to help us when we get to big calculations. But all it actually did was take the 4 and add the 0. And then it took this 4 and added 8 to get 12. And then we added 3 to get 15 and then added 5 to get 20. And we just keep adding as we go down. And so all cumulative frequency does is it adds each new row to the data. And the last value here should be equal to the total that we found, which it is. And so a cumulative relative frequency then just means add each relative frequency as you go down. And so the first one again will just be the first value. You can click on it, you can type 16%, just depends if it's exact or not. And then equals the one above it plus the new row. So the 16% plus the 0%. We're doing relative frequency, so we're doing the percents now, or decimal. Hit enter, and then come back to it and drag it down. And you'll get all of your relative frequencies. And if you did it right, it will always end at 100. If it doesn't get to 100, there's usually some kind of rounding error that you'll be careful about. But that is how we do the cumulative relative frequencies. So this thing itself is called a frequency table. In general, we either just do frequency or relative frequency. But once in a while, they'll ask you for these last 2 bits, which is why I showed you how to do them. But in general, you just really need to know how to do the first half of the calculations up to relative frequency. A histogram is just a graph of one of these 2 things. Why one of the two? Because you'll see in a little bit, the graphs are actually identical. But let's make the graph now. And so we finished this table. We did the frequency table. So now we're going to go through, we did that too. We're actually going to make our histogram graph. And we're going to do it by doing the bar graph feature. So in other words, what that means is we're going to highlight just the frequency. Let's just do the frequency for now. And go insert. And then we're going to pick not the histogram one here. If you do this one, it's going to mess up. You don't want to pick the one that says statistical chart, as tempting as it is. What you actually want to do is pick the very first bar graph here, one called 2D column, and then pick the very first set of bars. And it makes this bar graph. To turn a bar graph into a histogram, we need to get rid of all these gaps except for where there actually is no data. So the only place we had no data was this 0 here, right? That had no data. Everywhere else we had data. So the way we do that, there's two main methods. First one is under chart design. You can go over here to the left and see quick layout and find the 8th option. That gets rid of all the gaps. You can go 1, 2, 3, 4, 5, 6, 7, 8. And that will make it that way. Some people don't have this quick layout option, especially if you're doing the Excel.com version. If you do that, then another way to find it is up here in search. You can actually just type the word layout, and then there's quick layout, and then you just pick the 8th one. Either way, Macs sometimes a little hard to find. If you keep clicking it, you can eventually find the feature and then remove it in chart. I think it's under access titles. If not, we can play with it privately, and I can show you how to do it if you're on a Mac. But in general, either searching for it up here in layout or going to quick layout on the left, you'll find the option you need. And so notice we have no gaps everywhere except for that one row where we had no data. That one row that had 0 data is clearly shown. And so this is how we make a histogram in a nutshell. And then you go through and add the titles based on the information that we knew. If we knew this was like, blood pressure, you put histogram of blood pressure or whatever. On the left, this part will always say frequency because that's what we're graphing, or relative frequency, depending on which one you graphed. And the bottom here would need to be classes. One thing to notice, though, our classes start at 1, so we're actually fine. Later on, we'll need it to say 0, but for now, for the first unit, it's going to be the right number. We see there are 6 classes, we see 6, and so that's fine. Sometimes they don't want it to have the class numbers, and they want it to be the LCL, UCL numbers instead of classes. In order to change that, what we'll do is right-click where it says the class number like 1, right-click on that, or 2-finger click if you're on a Mac, and go to Format. Actually, no, go to Select Data. I almost had a brain fart there. So go to Select Data, and you'll see when this menu pops up that it says horizontal. And underneath you'll see 1, 2, 3, 4, 5, 6. It's all the horizontal values. We're going to click Edit on that. And then we're going to select the LCL and UCL values and hit OK. And hit OK. And what that does, it changes it from showing you the class number to showing us the LCL, UCL range for each of these. And so I'll do that one more time. There we go. And so again, it defaults to showing you the class number. If you right-click or 2-finger click, depending on what kind of computer you got, and then go to Select Data, and then edit the horizontal axis labels. Once you click that, this little box pops up where you can highlight the LCL and UCL numbers, and then just hit OK twice. I'm going to hit too many times. There we go. And it will update from classes to LCL and UCL values, which is what we want. And so that would be our final product of the histogram. Because this is more meaningful for a reader. For reading this, we want to know what ranges did you use to get these numbers? Because again, your class width is arbitrary. You pick. And we picked 15 for this example, but you could have done it with 16 or 17. And the bars would look slightly different depending on which of those 3 values you picked. But I mentioned that the relative frequency and the frequency distributions would look the same if graphed. Let me show you that really fast. I'm going to go Insert, highlight my relative frequencies now, and then click the same bar graph option and pick the first one. And then we're going to remove the gaps again. quick layout number 8. And notice the shapes of the graphs are identical. The only thing that's different is the frequency one counts by whole numbers. We have 1, 2, 3, 4, 5, 6, and so forth. While the relative frequency one counts by percentages or decimals, depending if your data is in percent or decimal form. So this column here and how we're counting is different. But what we care about in statistics is the shape of the graph. And so we see that we have the same exact shape on both of these. And so the shapes will never change regardless of which of these two graphs you graph. The only thing that changes is this Y column, this frequency or relative frequency column. That's in a nutshell how you make a histogram. Build a frequency table and then graph either the frequency or relative frequency. If they ask you for a frequency histogram, then you graph the frequency numbers. If they say find a relative relative frequency histogram, then you graph the relative numbers, the relative frequency numbers. All right, last problem of the night, and then I'm gonna be done and let y'all go and practice some of this some more. Again, I'm recording all this, so you can go back and watch the recording to get anything you want to review. And just to remind you, I do all these things every single week, new questions. In the same week, I'm doing the same questions. So this Saturday, actually this Friday, because there's no school Saturday, I'm doing the same stuff again. So there's no real benefit to come twice unless you just want to watch me do this twice. But next week, I'm doing new questions and new problems to get some more practice of this kind of stuff. So we're going to go through this. I know 7:30 is our official stop time. So we're all adults here. If you need to go, I understand. Head out. I will stay and finish this last question just so we have completeness. But wonderful working with everybody today. No one interrupted me, so I hope I was making sense and all that stuff. I am going to put in the chat after this a post survey just so I can get feedback on areas that made sense and didn't make sense. So I know where to kind of tack on new stuff for next week in addition to what I already planned on doing next week. Okay, let's get into it. So first off, they say using Excel, we're going to make a frequency distribution. That's that frequency table we just made. And then we use that to make our histogram. So over here on the right, we're going to need to find our LCL, our UCL, and then we can do our frequency distribution. I want to make this Y a little bigger to fit the data, and I can either manually drag, or a cool thing about Excel, if you double click really fast, it will auto size to the size of the stuff in the cell already. And so that's one way of doing it. And it says I want to have 6 classes. So I'm just going to number here 1, 2, 3, 4, 5, 6. That's the number of classes. That way I make sure I go far enough down. It's auto size that word to fit. And so now our LCL is generally going to be our smallest number. And the data appears to be in order, but if we weren't sure, we can make sure by saying minimum of our data. And there's our smallest number. And we need to figure out the class width. And so remember, the first thing to figure out then is our range. And so that's going to be the biggest number, which in this case is 94. So 94. Take away the smallest number, take away the 40. Didn't need parentheses, I don't know why I put that there. So we now have our range, 54. We're told to have 6 classes. And so our exact class width, remember, it's just your range divided by classes. And it gives us a nice number. But in general, you want to round that up every time. So our rounded class width would be some number bigger than 9. That's just a nice number to work with. Most people hopefully would just think instinctively 10. But it actually would work with 11 and 12. Just decide what you want to count by. In this case, counting by 10s is pretty nice. And so this tells me what to count by every time. So going down, I want to add 10 every time. And even though it's easy to add 10 manually, I'm going to make Excel do it because I'm lazy. I'm going to click on that 40 plus 10 and hit enter. Now when I go back to it, I can grab this little dot and drag it down and get all my calculations done instantly. Now, if this is a 50, that means the one before it had to be a 49 because it has to go up 2, right? And then I'm going to add 10 every single time to that number. And then I can take it down and get all my LCL and my UCLs. Now, using my data set, I just need to find the frequencies of each one. So how many numbers are from 40 to 49? There's 2 of them, so I write 2. How many numbers are in the group of the 50s? 1, 2, 3. How many are in the 60s? Highlight, and I see there are 6 of them, so I can write down 6. How many are in the 70s? Going all the way to here, and it says there's 16 of them. How many are in the 80s? Just highlight. And again, we're looking down here, we see there's 18 in the 80s. And then how many numbers are in the 90s? We have 10 numbers in the 90s. So now we have our data and our frequency. Do they want relative? They want relative frequencies. So we got to find our relative frequency. Just writing little labels here so I know what I did. And we should make sure we have the right sum. So we're going to write sum to make sure we have all the frequencies counted properly. 56 numbers. If I click on Q where all the data is, it says there's 55 numbers. That means I miscounted somewhere, right? Because that count should be identical in both groups. So really fast, let's just double check. 2 numbers in the 40s, okay. In the 50s, I see 3 numbers, so that looks like it worked. In the 60s, I see 6 numbers, I'm good there. 70s, 16 numbers, so far so good. How about the 80s? All these 80s, 18 numbers. Ah, see, I put 19, I miscounted. So I'll go back and correct that. And now I have 55 numbers, which matches my count, so I know I got the right number now. It's always a good idea to check your work. It's easy to miss one. Relative frequency is just the frequency divided by the total of 55, but we don't want the total to change, so you write the total in. Hit enter, and I can go back and bring the decimal down. If they want decimals, that's good. If they want percentages, we know we can go to home and click percentage or find it in this list. If I click percentages, I have my percents there. They'll tell you whether they want it as a percentage or as a decimal. Just go by how they ask for it. And this time, I guess because last time I did percentage, let's leave it as a decimal this time, just so we can have experience changing it. And maybe I only want 3 decimal places. So make Excel do that rounding for us. But there we go. We have our relative frequencies. And so now I can create my frequency histogram. They want a frequency histogram, so I want a histogram of the frequency. So we highlight our frequency numbers. We go to insert and pick our first bar graph and select it. And then we want to get rid of these gaps. And so quick layout number 8 will get rid of your gaps. And so now we have a frequency table. And again, like before, we don't usually like the classes down here. We usually want LCL and UCL. So we're going to right click on one of these numbers, select data, edit the horizontal axis labels, and then just highlight your LCL and UCL numbers and hit OK. And hit OK. And there is my data written with the LCL, UCL numbers instead of the classes. And that's ultimately what you want. And of course, you update your titles of your frequency, LCL, UCL, and up here, histogram of whatever the story is, histogram of, ages or whatever we're told this is. Okay, checking the chat real fast. No questions. So I've done A. Now it says find the mean, median, variance, and standard deviation of the sample. So they're telling us it's a sample. What does that mean? Well, remember on these formulas for standard deviation and variance, we have 2 different formulas. We have them for the sample and for the population. So they have to tell you which one to use. And now they're telling us it's a sample. So we're going to use the sampled formula on this particular problem. If it said for the population, then you would use the population version. So we're being told to find the mean, the median, and the variance. We often just call it VAR, and our standard deviation. And so our mean formula is equals average, right? And just click where your data is. All your data is in Q, so click on Q. So again, it's to your benefit to put the data in one nice area. If it wasn't, it was like in this kind of box format, you would highlight the whole entire rectangle there. Like if my data was like spread out that way, I would just simply say equals average. Then I would highlight the rectangle where the data is. Just depends on how you write it. It's just easier when it's in the column. Anyways, we're doing median now, so equals median. Click on my Q to get all of Q and hit enter. Variance, well, since it's a sample, it's var.s for sample, and then Q and close it. Standard deviation, standdev.s, parentheses, Q, and close it. And those are those calculations they're asking for. We calculated them, we labeled them, so we met the conditions of part B here. So check. Now the 5-number summary, and let's do it by formula. Remember the elements of the 5-number summary. We need the minimum, we need the first quartile, the median, which even though we already know, we're just going to put it in this list, third quartile, and the maximum. And remember, if we're using the formula method, we can say 1, 2, 3, 4. I'm sorry, no, 0, 1, 2, 3, 4. And one kind of nice way of making sure you did it right is first quartile is 1 and third quartile is 3. That's what kind of was a red flag to me. They should always match up. And so now we're going to say, notice the 0 is in P14. So when we reference it, we can type P14. Quartile.inc. All of my data is in this Q column, right? So I click Q. And then the 0 was in P14. Otherwise, if I wanted to make this fit, as I showed you earlier, we could actually just stretch the size of the cell. Because right now I can't click on that 0 because the formula is kind of like bleeding over the cell. And so if I really wanted to, I could just drag this wider. So now I can fit the formula in without any issue. Doesn't matter which way you do it, as long as you get the right answer in the end, right? But you can also just drag it so you can click P14 if you prefer to click then the type cells. Once you do that the first time, we hit enter, and then we go back and drag this down to get all of our calculations. And that represents your 5-number summary. So we now have the 5-number summary by formula method of our distribution. So last part, it's a concept question. It says, are we permitted to use the empirical rule? And you'll get really into this later in the course, but let's just kind of introduce it a little bit to you. So first off, for which type of distribution are we permitted to use the empirical rule? There's 3 things that we look for. The short answer is we look for what we call a normal distribution. That one tells us that the empirical rule applies really well. And we have things that could be approximately normal, similarly normal, it's a hard word to say, but ultimately normal needs to be in the title somehow. Now, what makes something normal? You get a more formal definition in class, but a brief introduction for it is you'll need to have 2 tails. 2, it has to be symmetrical, which just means the same on both sides, or at least almost symmetrical. So it can be a little bit distorted. There's not a lot distorted. And third, we need to have a peak in the middle. A peak in the middle. So in other words, we need a tail on the left. It needs to rise up to some kind of peak and then come back down to have a tail on the right. It's a poor drawing, but that's the general idea. Notice that we have a tail here. That's called a left tail. And we have a tail here known as a right tail. And we have a peak, a big, tall, pointy thing dead in the center. These 3 things combined are good. So we have like a generally symmetrical. In other words, this tail looks roughly like this tail. So check. We have 2 tails, and we got a peak in the center. If those 3 things are there, we generally call it normal, or at least approximately normal. And so that would tell us that we can use the empirical rule. The other major ones that often happens, there's more than the ones I'm about to show you, but just two other ones due to time, is that we'll have cases where we have like a tail on one side and a peak at the end, kind of like that. So notice we have a left tail and then a peak over here. Left tail. When we describe these things with tails, especially when we have one tail, we describe them based off of the tail. So this shape here, because it has a left tail only, we call it left skewed. That would be the name of that distribution. It's a left skewed distribution. And so if we have a distribution that has a long right tail and then the peak's over here on the left, because the tail is over here on the right now, we would call this a right skewed distribution. So we call it based off of whatever tail is there. And if it has two tails that are approximately the same length, then we like to call it the normal or approximately normal. Another common word that you would see is bell-shaped. If you think about those old, like 1800 bells that you might see ringing with that long thing there, that's like a bell that's bouncing around inside there. That's what we call it, bell-shaped. Mathematicians are not creative. So now if we look at our picture, our histogram we drew, what we're talking about with this distribution thing, which of those three distributions are we talking about? Well, we have a peak over here, and it goes down a little bit, but for the most part, we have this long tail on this side. So this has a long left tail, no real right tail. It doesn't really come to the ground. So you wouldn't really call that a right tail. So this shape then is a left-tailed histogram, and AKA the way we describe the distribution is left skewed. We always describe by the tail. So this has a left skewed distribution. And so when can we use the empirical rule? We can only use the empirical rule when we see two tails and they're symmetrical and the peak's in the middle. Well, this has only one tail. So can we use the empirical rule? No, it does not apply. Does it apply? No. Why? Because it is left skewed. In other words, you're telling the reader it only has one tail and the tail is on the left. It's left skewed. So you cannot use the empirical rule because of that reason. And so what would you use? Why do we care about using the empirical rule or not? When we like to describe the data and how it looks, we either use the empirical rule, which means we convert to the z-scores and describe things by z-score. You know, and there's a whole things you can do with the z-scores, but we'd use the z-scores to describe it. If you can't use the empirical rule, the other way to describe the spread or how the data looks is the 5-number summary. So when the empirical rule works, we're going to utilize the mean, standard deviation, and find z-scores. When the empirical rule doesn't work, what we use instead is the 5-number summary. And so we would use the median, the quartiles, the minimum, and maximum. So if we have skewed data, you should use the 5-number summary. If your data is relatively bell-shaped, then you use the empirical rule, which means you can use mean, deviation, and z-scores. So I know it's a crash course and a bunch of things, but I recorded this so you can go back over it and review some of these things. But this stuff, again, on page 24, is all the formulas you need to know how to use. And we just went through each and every one of them of how you need to use manually in Excel. None of this stuff you should be calculating by hand or with a physical calculator. Excel does all of this stuff for you, and you're using Excel on the exams. You're generally not going to be allowed to bring your own handheld calculator. So you do want to practice using Excel with these calculations. And if you keep coming to my boot camps, you're going to get really good at it because we're going to do Excel like crazy every single week. Every Tuesday night or generally Saturday morning, I do these boot camps. This week's boot camp's on Friday because, again, there's no school on Saturday. It's technically closed for MLK weekend. And so I moved it to Friday, but it's the same thing you just learned today. So there's no new information this Friday than what I just talked about today. So it's always one or the other. Pick Tuesday or Saturday, come on up. These are optional, but I hope they're beneficial to you. But that's all the major calculations in a nutshell. I'm going to stop recording And that's it, y'all.